All right, so here we go. Hope you guys did well on homework 11-2, and we're going to do a little algebra review, particularly radicals. And the first thing I need to do is make sure that you see my shirt, although you're seeing this in class on Friday. Get it? And oh, my executive producer for this this video is Caroline Spertus. It's kind of like Back to the Future for Caroline because she's filming this now. She's having the radical test in Algebra AB on Monday, and yet she'll see this next year, hopefully. So thank you, Caroline, for your help. You probably remember this sheet from Algebra AB last year. I want you to make sure that you've got all of these down. This will be really helpful in this unit and for the rest of the semester in honors geometry. So we'll make sure that you have these. In fact, maybe at the end of class, your substitute for 2012, which will be Mr. Hoganson, we'll maybe do a little oral quiz. And I certainly will when I come back tomorrow. Okay, so make sure you fill those in. If you'd like the video paused right now, go ahead and have Mr. Hoganson pause it while you fill them in, but it's pretty self-explanatory. You hopefully remember them all. All right, on we go. There were these properties that we learned last year. Square root of x times the square root of x is equal to, Caroline?
X.
X. Excellent. Good job. Okay. An example of that would be square root of 3 times square root of 3, or negative root of 3 times negative root of 3 equals negative 3. Okay. And this is the sections from your algebra book, so if you still have that and you want to go look at this, you can. All right. The square root of x, quantity squared? Yes, it's also equal to x. And here's an example of that. Now, the square root of x squared, where the entire x squared is under the radicand as compared to here, where the squared is after you take the square root. Caroline?
Absolute value of x.
Absolute value of x, yes. The absolute value of x. The reason being, if x starts out as a negative, like negative 3, when you square it first under the radical, because remember the radical is a grouping symbol, it becomes 9, and the square root of 9 is equal to 3. A couple other handy rules that you'll want to remember. Square root of xy, or a product here, you can split it. And there's an example of that. So square root of 27, you can make square root of 9 times 3. You could then split that to root 9 root 3 and make it 3 root 3. And if it's division, of course, you can also split it and make it two fractions, two radicals within a fraction instead of one fraction. Okay. Other basic terminology. Hopefully you all know this. This thing is called the
Radical.
Radical, or radical sign. Excellent. Either way. This little thing, again, this is more of an Algebra 2 concept. It's called the root index. The root index in all situations that we'll deal again with in honors geometry are, we can just assume it's to the second, or that we're taking the square root. But I think last year we talked about cube root in terms of how we could do that, or a fourth root, a quartic root, and so forth. This number under here is called the radicand. Hopefully this is all very familiar to you because you had such a wonderful Algebra AB teacher. Moving on. Simple rad form. There's two parts of simple rad form. You remember what they are?
Mm-hmm. No.
Good. I know you do, Caroline. Hopefully they do a year later. First one is no perfect square factors in the radicand. So you can't leave something like the square root of 8. It's got to be, you can break it down to root 4 root 2, and then root 4 becomes obviously 2, so it's 2 root 2. And the second is no rads in the denominator. You've got to rationalize your denominator. This I'm not so worried about, but just remember rational rad would be something where you can take the square root and you get a rational number. So square root of 4 is equal to 2, so root 4 would be a rational rad. Irrational rad would be anything that's not a perfect square number, such as the square root of 5. And non-real or imaginary rads would be the square root of any negative. All right, great. Are you ready to try some examples? Let's do it. So we go to our class examples here for simplifying basic rads. We're not going to do all of these. fact, this is the same sheet that you've had. You're going to get a practice sheet for part of your homework and classwork. Well, let's start. So square root of 12, is there a perfect square factor in root 12? That's always the best way of doing it. Yes, it would be root 4 times root 3, which ends up being 2 root 3. And of course, if you don't see a perfect square right away, you should in this one, but if you didn't, you could always go root 2, root 6, just start breaking it down, then make a match there. Remember, root 2 times root 2 would be equal to 2, and you get the same answer. But always best to find the biggest perfect square factor that goes in. We can go ahead and skip 2, 3, and 4. They're very similar. 5 might be fun for you to try. You might not recognize a perfect square number that goes into that, but you hopefully see that 3 does, because 5 plus 0 plus 7 is 12, and that's a multiple of 3. So, oh my goodness, look at that. So that becomes 13 root 3. So 7 and 77, no perfect square factors there. So what do you think you would do? Well, try and be what I call this year a radical sleuth. Look for matches that you can find. So 77, it has a 7 that goes into it. So maybe we should break that up to root 7, root 11, multiply those two together, and voila, you have 7 root 11. Okay. I'll let you play around with some of those. I think that's probably enough in terms of lessons on that. I can uncover some of these, though, so you can see what the answers are and how you go about doing these. And remember, with radicals, what's nice is there's often more than one way of doing them. Here we got an addition problem, though, so this is a little different. Okay? So we have 5 root 3 plus 7 root 3. Well, remember, root 3 is an irrational radical. We don't know exactly what it is. We know it's 1 point something, well, and so forth, but we don't know exactly what it is. It's irrational. So you can think of it as a variable. So think of this as like 5x plus 7x. They're like terms because they have the same radicand. So you can just add those together and get 12 root 3. This one, always best when it's addition and subtraction also to break them down, simplify them separately. So you want to make this into perfect rad or simple rad form. So root 9 root 3 would make us a root 9 root 3 and then a 3 root 3. Like terms again, 11 root 3. All right, let's look at some ones that are a little bit more difficult. Again, break down each term. 4 root 6, well, nothing we can do with that right now. Square root of 150, let's see. 25 goes into 150 and it happens to go in 6 times. How convenient. So we would have 25 root 6, which would end up getting us negative 5 root 6, and then root 24, let's see. 4 and 6. So we'd have root 4 root 6, which is 2 root 6. Notice we have what? 3 like terms. All right. And for now, for a little break, let's take a second to go ahead and film our camera woman. Thank you very much, Caroline, for all your help with this. All right, back to the lesson. All right. Multiplication. Okay. Outies with outies, innies with innies. Remember that one, guys? Okay. So I could multiply root 18 times root 14, but I get a kind of big number, then I'm going to have to break that one down. So probably not the best way to go. I might want to just kind of look and be a radical sleuth, find any common radicals that radicands that they might have, common factors, which you can see would be a 2. So you might want to break down the root 18 to root 9, root 2, the 14 to root 7, root 2. Make sure that you're very careful and multiply all of these numbers in one form or another. So we would make sure to bring this down. The 6 would come down, the root 9 becomes a 3, the root 2 times the root 2 makes a 2, and then bring down the root 5, and the root 7. Outies with outies, innies with innies. Multiply all the outies together. 18 times 10 is 180 root 7. Okay, let's see. Are there any others that we need to worry about? This is a good one to look at. Everything's being squared. So think of the 3 being squared and the root 5 being squared, which would be, like, one way would be to write it out like this. 3 outies with outies, innies with innies. You get 45. Okay. And you can try some of these other ones on your own. So you may want to pause the video here and have some of the students try it. let's uncover it and go ahead and try some of them on your own. And with that, I think that'll be the end of our first video lesson. So make sure that you practice these, and then Mr. Hoganson will have more information for you in terms of what your classwork and your homework for tonight is. Thank you very much, Caroline. We're all set.